Thank you very much for joining me this afternoon, morning, depending on where you're at. Really grateful to have a few minutes to talk through some of these things. I find this area of inquiry really interesting. It's a fascinating space to be in. We are going to talk a lot of zero trust concepts. I'm not a huge fan of the term, I suppose. It tends to be overloaded. And I think all of our IT terms get overloaded very, very quickly. Microservices architecture, zero trust, cloud operating models. We kind of generally are digital transformation, very, very overloaded terms, and they can mean a lot of different things depending on the lenses that we look through. The lens that I'm going to use today is going to be focused on how and when and why do we establish trust at all, from the infrastructure layer all the way out to identity, networking controls, and so on. So we're just going to talk a little bit about trust, but we're going to do it through a lens of automation. Now, as we dig in, we know that we want to go very, very fast. Every survey that gets done, every time we interview CIOs, the concern is how quickly can I adapt? How quickly can we change? If you're talking to a CISO, the question is going to be, there are going to be new approaches to breach patterns. We had that Uber breach here recently, which is kind of an interesting social engineering leverage to get access to the VPN, and then that leads to some additional challenges for us. So we keep having new avenues, new attack patterns. Many of them are repeated, but I think a lot of what we're trying to accomplish in enterprise IT is, how do I iterate? How do I do something new? And how do I do it with safety in tow? Because we know the faster we go, the more likely it is for us to introduce some form of frailty. Gartner would say most of the security, yes, there was some initial concerns in the early days that the cloud is a pretty big target, right? So if we're talking about hackers and threat, the clouds are a good place to go because there's a lot of assets of a lot of different companies in there. So yes, it is kind of a focal point. However, most breach that we're going to see is going to be self-inflicted. Most issues that we have for failure, resiliency concerns, outages are going to be generally self-imposed because we're going very, very fast. We're doing things that are new to us. There was an interesting blog that I thought was very insightful that looked at, as we adopt new services that we've never worked with before, we're dealing with things like unknown failure domains, right? So I pick up a new style of database or analytics service, and I'm not exactly sure when I push this one over. I understand my older technologies, Oracle, very well understand how I can threaten a rack cluster. But if I start looking at something that's totally new, I'm dealing with failure domains that I may not fully understand. And so I push loads at things that can potentially lead to outage. And that happens. The faster we go, the more we innovate. But even as we look at the threat to our trust, or what we can trust within IT, it tends to be multi-factored. It's not just identity and credentials. They end up being leaked and used against us, an attacker on keyboard or supply chain style attacks. We have misconfigurations, right? So a misconfigured S3 bucket, a misconfigured WAF, boundary control, improper DDoS prevention and bot defense and things like that. We have inefficient or insufficient networking boundary controls and restrictions that allows a hacker to come in through a building, through a point of sale back to corporate. We have bad patches that get introduced. We have trust extended to third-party services that we rely on. And the point is not to make this any sort of like a scare slide or scare tactic. It's more to say that there's lots of ways that trust gets violated in the cloud. Something that we thought was trustworthy is not as trustworthy as we were hoping for, and we end up with breachable opportunities. And so let's look at a few of the obstacles of serving our constituents in a good, nice, clean way with proper guardrails in a multi-cloud environment. And we used to think of the private data center as something that was easier for us to defend. We had the idea of a physical boundary, sort of castle and moat, anyone that was outside of the building could not get on the network. You had to be inside the building on an Ethernet connection, inside the network and so on. Now, this does provide a little bit of an easier theoretical construct for what we trust in terms of networking. And so we had this idea that we were green, we were trusted inside the four walls, we were not trusted outside the four walls. And we thought of that as a little bit simpler. But was it really? Were we defended against bad actors inside the four walls? We started doing things like employing HSM, hardware security modules, to encrypt storage devices in case a disgruntled employee were to walk out with a disk or things like that, right? We really weren't doing a whole lot of thinking. We were doing a lot of thinking about insider threat type conditions. And then over time, we began to introduce a lot more holes in the network as we started moving towards remote work. People are not in the four walls. It's not an Ethernet drop. It's going to be an HTTP session from outside the four walls. And so I start having to think about even my private data center network as more ethereal, as less, a very, very porous networking. And I'm dealing with hundreds or thousands of changes that are happening to configs, to patches, patch systems, OSs, everything inside and out. So my point here is not really to hold up the work. I think Network Bachelor does a good job of explaining some data center reference architecture, but the point that I'm making here is that it's very complex. Tons and tons of moving pieces and parts, tons and tons of moving teams. People are coming in and out of the network. The network is much more porous. So I should really start thinking, even if I was local and only looking at a private data center, I have challenges of a porous network, and how do I deal with attacker on network, or the idea of attacker on network, insider threat. If I'm going to treat my infrastructure like someone is already on the network that shouldn't be on the network, that is probably a better mental model for the way that we consider how we're going to extend trust and under what conditions. And I think as we looked at the cloud, we already had the challenge in the private data center, I guess is the point that I'm making. And over time, we saw the clouds and the concept of extending our private data center into multiple hosted external cloud providers really put the spotlight on the fact that I can't really trust the network. I have to treat all network like public internet traffic. And if I'm going to do that, I have to think differently about my boundary controls. As an example, I really can't trust all traffic that comes over my, my dedicated interconnect from GCP, simply because it's coming across an IP that my DMZ recognizes, right? I'm going to have an additional layer of attestation of that traffic, or I may be exposing the data center to more, sort of think of it as like east-west traffic, north-south traffic. I'm going to be exposing my data center to more a heightened level of trust that may be unwise if we're going to treat all traffic as suspect. So without a trusted perimeter, without a trusted IP, I'm not going to trust IP anymore. And with data getting pushed around, I'm going to have to think a little bit differently of how and when and why data gets decrypted, how we're defending the perimeter, how we're managing all of this infrastructure and real estate. And I'm just going to have to think about it differently in order to establish trust. Now, this is going to be a little bit of a different talk than maybe sometimes I get a little, maybe cynical is not the right word, but a little cynical with how sometimes we respond to these types of challenges. We say, hey, zero trust is important. It's super easy for you to establish a trusted environment. You just need to define the org correctly with appropriate policy and boundaries and access rights and controls, and do the same thing at the account level. And as long as you know all the actors who are acting within the account and you've properly structured their roles with policy and access controls, et cetera, you should be fine. Then you're going to establish your virtual private clouds, the boundaries that are associated with those. Those are striped across availability zones. So I have WAN segments. I've got secrets material in both sides of the WAN separated data center that we've established here, a virtual data center. And I need to have ways for different groups to be able to communicate within there. So I'll need access to your secrets material. You'll need access to my secrets material, or I need to be able to create secrets on your side of the infrastructure and vice versa. So as long as we do all of that right, we'll be fine. We need a way to govern our infrastructure. So maybe we start defining things like security groups, and we stripe those security groups are ways for us to group infrastructure like load balancers, and I want to treat them consistently. So let me make sure that load balancers live inside the load balancer security group with appropriate policy enforcement. And as long as all that's done perfectly, we should be fine. And then my network strategy, how am I subnetting? What layers of indirection do I have in the network space? A lot of times, I often joke about this, and if you've heard me speak before, you may have heard me say this before, but oftentimes I don't know that it's the right answer to say the best way for me. I'm having difficulty defending my existing perimeter. So what I should do is add way more perimeter, and 1,000, or tens of thousands or hundreds of thousands of new networking controls. And then maybe if I do that, I'll just have defense and obscurity, right? Like the network is so spaghettied out that it would be really hard for an attacker to understand my network topology. But then again, I don't understand it either. And therefore I can't really defend it very well because I don't understand it. So maybe I get machine learning and AI to help me defend it. So I'm not sure that the subnetting strategy needs to be completely saturate your network with tons and tons of subnets. We might want to think about flattening that a little bit and just getting better at defending the perimeter. We can talk about that as we go forward. Then I'm going to have to define my network access control list, my load balancers, my firewall rules, the way that I'm going to ingress egress between these different groups. How are they interconnecting? Again, secrets material floating everywhere in here. I've got secrets on both sides, access rights, transgression between the network segments. And I have my WAF, my SIEM, my bot detection and prevention, my DDoS protections, my telemetry, my analytics to look at anomalous network patterns and see if I can identify signs of breach and all of those things. So naturally what I'm saying here is it's not easy. There's so many moving parts. And if I start looking at this, and I've heard a number of talks where folks have said, it's so easy, just follow these simple architectural patterns and you'll be fine. Maybe at a micro perspective, right? For an individual project, I can follow a handful of guidelines and be generally pretty good. But if I start spanning this out from an enterprise perspective, I've got dozens of teams making dozens of changes all the time. And I'm sort of hoping that they're doing things the right way. Now, I may end up buying tools on top of tools to watch everybody's activities and try to audit and try to provide standards and so on. But I have to do this over and over and over again, and not just within a single cloud, but generally across multiple clouds. So I'll have this approach in AWS and Google, and I'll repeat it in Azure. I'll repeat it in Ali if I've got Asia Pacific endeavors, and so on and so forth. And my on-prem, I'm going to do the same thing on-prem. And so what I guess part of my thinking here is we want to move away from direct access to sensitive systems by individual users, operators, developers, where they are directly logged into something sensitive and they're making direct changes to that underlying system. We recognize that that is where fragility gets introduced. If I have, 1,000 people that are doing operations for, a sizable enterprise, and they're all logged into various systems, making changes to load balancers and firewalls and perimeter defense controls, telemetry tooling, visibility, just anything and everything that we're using to operate at scale. That's a very daunting situation for me to be able to audit, control, assure my auditors, my compliance teams, my GRC groups that things are being handled perfectly all the time. And it's also a bit of a security conundrum for me because I have just dozens and dozens of passwords for every individual user needs to be in a VPN through an SSH Bastion host, talking to a privilege access management system, requesting and getting secrets and managing those secrets, so on and so forth. So I end up with dozens and dozens of passwords. Those have to be managed by teams. And so I start looking at just weight associated with managing an environment that is all individual operators or developers working against sensitive systems directly. I'd rather think about an abstracted model where I'm committing a change via intent. I'm saying, this is what I would like to see happen in the environment. Can you vet it for security, security parameters, all of our best practices? GRC needs to be happy with it. The cost can't be out of constraint, so on and so forth. Protect me from myself, please, right? Let me just declare this is what I want. This is the environment, about the size, what I need access to. I'm going to need this number of instances in this region. And then can you automate things for me? Now, the closer we can get to that type of a view, the easier it is for us to manage the introduction of change into our environments. And ultimately, if I were to come back and say the biggest challenge to IT is really not a technical one. We have a million ways to deal with secrets. We have a million ways to deal with networking. That's not the concern that there's not a tool. We don't have a tool to solve this particular challenge. We've got tools. The problem is we don't deal with managing change well. If I were to indict IT, generally speaking, it's we don't do a good job of change management. We're typically reactive. We introduce a change, there's a ripple effect, something breaks, we mitigate it right on the backside. So how do we think more first principles and govern the way that change gets introduced? And so if we start with how do I begin to trust my environments, I start by looking through things like infrastructure as code. Can I define an intention and then orchestrate or provide a system of coordination which allows all the teams that need to attest to the environment, give them the ability to attest to the environment in as automated a fashion as possible? So you'll hear a lot from HashiCorp around things that we call like the golden workflow. The idea is that I have an image that needs to be stamped into an environment. I'd like it to be scanned for risk and vulnerability and compliance. I'd like to have the entire infrastructure defined before, nobody can touch the sensitive systems on the back end. That's all going to be automated through pipelines and through a Terraform run or something like that. But I want that automation completely separated from the consumers or the people who are making the request. And I need to have a way that I can encapsulate all of the policy, concern, cost constraints, et cetera, and automatically audit the environment before it actually gets provisioned to any sort of running system. This gives me a much stronger defense posture because I don't have to have 32 open IPs for every developer in my environment. They don't need their VPN and privileged access management access to the database and blah, blah, blah. I'd like to find a way to kind of narrow the number of IPs that I'm leaving open, the number of passwords that I'm actually allocating to anybody. And if I can get to where I'm doing things like identity brokerage, where you just have your SSO, I'm going to strongly attest who you are, I'm going to provide you a token, I'm going to make decisions on permissioning in real time downstream from you. The closer I can get to that level of abstraction, the less open IPs, less open managed secrets that I have to deal with, et cetera. So just, again, notionally, how do we begin to coordinate, make things reusable, pre-build things as much as possible? If I can prepay the tax for, as an example, how do I want WAF and all the security measures around the WAF to be managed across the entire enterprise? If I can make that a pre-built component that gets consumed, it's a known state. It's got a known config. I'm well aware of how it needs to behave and perform and what the policies need to be around it. And I'm going to scan everything that goes out before and making sure that it meets all of our standards before I even allow it into my environment. So that's kind of one of the ways that we start looking at narrowing down trust. Now, generally, as zero trust as a moniker really came out around, I'm not going to trust the network anymore. And I'm going to be a default deny all policy on the network, unless I see a specific rule which would allow the connectivity between an identity and another identity. So again, not IP, but identity. So naturally, as we get into that zero trust discussion, we're going to pivot into identity. And so I'm going to need to think of identity holistically, not just SSO, not just YubiKey and multi-factor authentication, but also how to identify trusted infrastructure, machine images, OSs, those types of things. Microservices, a Kubernetes service is an example. I'm going to err on the side of maybe JWT or JOT tokens in that case. So I'm going to have different forms of identity for different styles of access. Maybe I want to implement something like mutual TLS, which requires X509 certificate. So we're going to get into multiple different types of identity, and they're going to be using IP addresses, which are going to become much more ephemeral, right? And traditionally, we thought of IP as static. In fact, if we go back to virtual machines and talk a little bit about how virtual machines were managed, we had the idea that when we moved to VMware or vSphere or whatever you were doing in that space, OpenShift, however you were taking on the challenge of virtualization and virtualized workloads, we had the idea that we were going to go to, OpenStack, I guess. OpenShift is more the Kubernetes side, but regardless of how you were doing the virtualization, we had the idea that we were going to make these machine images much more mutable. It's funny how I think we actually went the other direction. Like I worked against VM images, which had the underlying hardware platform had been replaced 2 or 3 or 4 times, and the VM is still with the same IP address. It could be the same OS, patched or unpatched, had been there forever, and we were just using vMotion or the virtualization tools to keep that as static as possible, right? We had set it up resiliently, and that IP endured. And so consequently, I could base things like my access controls and trust on the IP because it was so static. It really wasn't moving very much. And yet in a modern environment, those IPs are going to be very ephemeral. We're expecting them to be created and die. When we have scaling policies take place where servers drop out and then are recreated someplace else, I have new IP addresses. Or maybe I'm actually moving between cloud regions and I have to remap how to connect to somewhere else. And so I'm thinking about all of the various ways, all the various bits and pieces where identity is going to be used, and often will have a different form factor. There's a lot of thinking in the space of, well, can I just unify everything behind an Active Directory, service account or something like that? And that's certainly an area where good work is going in, and we are seeing some of those identities flex across, in some cases, even clouds, right? GCP. There's some interesting partnership between Microsoft and like GCP as an example. And yet I still have private data center concerns. I still have so many different ways that identity is being leveraged. And one thing that I want to call out is innovation moves on. So there's always going to be a new way. We always assume that we're at the pinnacle of technological evolution. Kubernetes is the greatest scheduler ever. There's never going to be another one. Well, I feel like I've heard that before, right? Like Java, write once, run anywhere. You'll never need another expression outside of a jar or near file. Well, it does move on eventually, right? Eventually we'll come up with a better scheduler, a cleaner expression, and we'll need to move on to whatever the new thing is. And you'll see one of the beautiful things about the cloud is that it's constantly moving. New things are always coming. And so I need to think more abstracted, right? I don't want to bake myself into a single approach to managing identity. I need to think about, how do I continue to flex with what I do with identity? Can I constantly uptick new abilities and pivot with the market? And so as we start thinking about things like Vault, and it was funny, I was talking with a bank earlier today about how they would just kind of laugh a little bit when we talked about HashiCorp Vault as an identity broker, because they really thought of it as a secrets manager. But as you really start to get into Vault and see how it unlocks the ability to bridge from one identity to another, and actually to make those interactions increasingly dynamic, the power of Vault is really that brokerage style use case. So I have a centralized entity, which represents, as an example, a machine. And this is what that machine has rights for. I've decorated that policy with a number of different things, and that entity is present. Now, when I ask to flex that to, let's say, a different cloud region, or it's looking to write to a database or something like that, how do I bridge from that particular identity into other forms of identity, or use that identity to determine whether I need to create another identity in response to a particular request or something like that. Some of the use cases that if we have time, I'll touch on are things like, I don't know, some of the financial payment networks will have a situation where I need to update a mainframe on the private data center for, quarter end record keeping, the way that I'm producing my books and so on. And so I have all these credit card transactions happening out in, let's say, GKE, using JOT tokens for identity, and we're doing things about like encrypting transaction traffic and so on. But when I want to write that out to the mainframe, I'm bridging the JOT token out to the private data center, and I'm actually creating a RACF credential to write to the mainframe. And I know not everybody here is going to be working against the mainframe, but the point is the identity paradigms are very, very different between what we're doing in the cloud and what we're doing in the private data center. And if I can get truly dynamic with how I manage identity and how those identities bridge one to another, I do a lot around centralizing audit and control and chain of custody on what that identity, how long did that identity live, what did it have access to, what did it reach out and create? And I get a much better sense. There's a whole wing of technology that scans your environment and tries to map what identities call what identities under what conditions to help auditors figure that out. But if we go back to first principles and say, how do we actually introduce that change? How do we manage it as a centralized workflow and deal with kind of identity brokerage across various forms and factors of identity, human to machine, machine to human, and so on, that we get this really interesting opportunity to get proactive with the way that we manage and deal with identity holistically. So I've spent a little bit of time with setup. As we get into this, we're going to talk about identity in a number of factors: applications, users, networking. And really, Vault is truly optimized for machine level identity. And that goes to a lot of the design decisions for the way that Vault was built, how it scales, how quickly it responds, the idea that we can manage millions, and in some cases hundreds of millions of identities at scale across multiple clouds. We're thinking about that quite a bit differently than if we were focused on end user credentialing, as an example, right? You're going to have, even a very, very large organization is just going to have a couple 100,000 people. They're going to have multiple, so maybe you're talking about 1 million identities for a couple 100,000 employees. That type of scale just gets nuked when we start talking about systems and services, active services in the cloud. And then we're going to talk about networking. As we talk about how we take identity and extend it into networking control, we're talking about leveraging, machine identity and coupling it with what amounts to a layer 7 networking intention tool, which allows us to define what access controls should look like for this particular identity, and then flex on how that goes out. And then we want to rethink how we look at privilege access management. So when I do have a break glass type scenario where a user is going to need to access something fairly sensitive, and I want to manage that end to end, I'm going to need a strongly attested identity. And then I'm going to need some form of a system which is going to allow me a least privilege credential injected style experience, where really all I'm working with is a single identity, like their SSO. And then I want to automate everything behind the scenes on how I securely tunnel you to a backend system, and then provide least privilege access to that backend system. So holistically, as we start thinking about trust, starts with identity, extend that identity into connectivity, and then use that activity as well to generate things like least privilege access patterns with sort of that privilege access approach. So what factors are accelerating multi-cloud security? Obviously, we're adopting things that are wide, in a widespread way. Most companies are not going to be on a single cloud. Oftentimes, as I talk about this, even when we have dedication to a single cloud, approaches to identity between organizations on that same cloud are so different. We're treating them like completely different data centers, even on a single cloud. And then we still have a lot of private data assets as well. Often when I look at a private data center, I was joking around with a CTO friend of mine about how many private clouds they had. They had 2 physical data centers. They had pulled everything down to 2 physical data centers, but within those 2 data centers, physical presence data centers, they probably had 20 different clouds managed differently by different tool stacks. You know, I have my IBM group and some Red Hat, and I had some VMware and some Tanzu and some traditional vSphere activity and so on. And the point is I end up with like dozens of control planes, dozens of different teams doing dozens of different things, operating basically like independent data centers, even in a co-load location. And we do the same thing in the public cloud. So regardless of how we see the stratification between on-prem and off and what we're doing from a multi-cloud standpoint, we end up with inconsistency across what we're doing operationally in the cloud. And we have this hugely expanded attack surface because we're consuming a lot of third-party services. We're consuming a lot of partner services, which are being managed for us. And we need a way to treat them sort of consistently and assure ourselves that we're managing things appropriately across our cloud real estate. And so if I start looking at the identity-driven controls that HashiCorp would refer to as our HashiCorp Cloud Platform, well, HashiCorp Cloud Platform is our SaaS provided model for how we're providing these tools in an on-demand fashion, where you can go in and self-serve and say, I would like a command cluster for Vault, and it stands that cluster up for you, and it makes sure that it stays resilient and so on. Gives you the keys to the kingdom, and whatever you do there is for you. We don't have access to any of your data, things like that, but we're managing basically the platform on your behalf, and then you can go out and leverage these products without having to do the operational overhead of running your own cluster, let's say in an on-prem cluster. This is allowing a lot higher adoption of the products as we go, as people begin to trust the SaaS cloud pieces. And if we're looking to bucket the products that I guess we would look at as more directly focused on identity-driven controls, which you could think of as zero trust, then that's where these products generally fit. And then we would partner with whatever you have for your SSO. So Active Directory, Ping, Okta. We feel like the SSO market is fairly well defined and fairly well matured. And so we want to leverage what you have there for multi-factor attestation of user access. And we'll just incorporate that into what we do from an identity standpoint, broker them to a machine image, broker them to a backend least privilege access type pattern to a sensitive data system or what have you. So generally speaking, if we look at those identity-driven controls, this is how they bucket out for a HashiCorp product strategy. And then we provide these tools except for Boundary. The rest of the tools are provided for on-prem install. And there's enterprise licensing for those pieces. And then there's also the cloud SaaS provided service. And Boundary is coming out of beta here shortly at HashiCorp. So if we start talking about this, we want to be secure by default. The way that these things get implemented, the way they get stood up, the way the platforms get managed, we want to instill a lot of those best practices from the ground up. And we're doing more and more within the tools so that those best practices are default settings. And if you're using our hosted platform, then we're applying the best practices for things like resiliency, high availability, et cetera. Otherwise, you know, if you want to run these yourself and you want to download the enterprise packages and run them yourselves, then we have plenty of best practice guides to help lead you to how to run them with a secure by default stance. Now, if we take a step back and think about trust, one of the best ways to look at this is to there was a really funny article a while back that was called well, there's a logical pattern called the anti-problem problem, I think is what it's called. So the idea is when you're dealing with something very complex and you don't know where to start at solving it, think of something just really big like ending world hunger or something like that, where there's so many factors that go into it that it's just overwhelming. You're not exactly sure how to start. There's this idea of the anti-problem problem, which is, let me flip it on its head and look at it from the negative case. What if I wanted to cause a major problem, what would be the best way for me to start it, right? How do I kick this off? And so if we're looking at zero trust, sometimes it's easier to say, what is the easiest way to breach our systems? Well, a leaked credential. If I get a user, if I can do a phishing attack where I get a leaked credential, that might be a great way to initiate some form of dangerous, deep attack. And then if I can use that initial access to escalate or create an elevated privilege using access to, it grants me access to Active Directory or something like that, then cool, I'll go into Active Directory, create an elevated elevated permissions for myself. Then I'm going to use those credentials, or I steal credentials or use those credentials to create like a trusted workload on the network. And then I'm going to use that trusted connectivity to pull, you have your data is encrypted on HSM, but if I send a select star from customer where clause over a trusted IP to that data system of record, after I've created a credential on that backend system, then awesome. Your HSM will gladly decrypt it for me. I'll take the information in the clear. I'll fill up a buffer, and then I'll flush it out over the internet. So if we look at the negative pattern and say this is generally how a cyber attack goes, we can start considering things like the controls that we're going to implement to make those windows. I don't know that we're going to get to the point where all of those windows are absolutely closed. Like there's no way that a credential could ever leak. There's no way this could ever happen. We have to consider that it's always a possibility that some of these events can happen. But if we think about our protection strategies, we want to make those windows as close to closed as possible while still being very dynamic and easy to use, right? So if we think about, as we start with the initial access piece, it's how do I attest to a new service and or a human actor, vet their identity, and provide the appropriate level of access control to a particular system. And as we think through these, we're going to talk about a number of things. One is if we come back to that initial primitive of how do we introduce change. One particular insurance company that I've had an opportunity to work with, brilliant team, made it so that, as an example, when we onboard a new developer, we run through an automated chain to provision their accounts and credentials and secure and lock down their software development lifecycle tooling. And we make it so that no one can come in through all of these other sundry tools, like as an example, Git, to add like an administrator that can see their repos or take action on their state or any of that type of thing. We want to make sure that we kind of lock down the rules of how we add people to a particular system, and make sure that those things are happening in a good, clean fashion. And also in a way that I'm not having to manage all of those keys and passwords all the time. So I don't want to make I guess one thought that I'll say as we dive into these, and we'll go faster as we go into some of these other pieces. We want to lower the tax of the best practice. And what I mean by that is if it takes me a couple of days to get access to a database and I'm submitting a ticket to a DBA team, I'm waiting for them to determine whether or not I should have rights to the underlying data system, and they give me a least privilege access pattern. So I get a user ID and a password. I implement that, and I realize my use case is a little bit broader than this, and so it takes me another few days to right size the privileges. Well, that's a painful interaction typically for a developer community. And so what they are going to end up doing is give me a time to live that is 10 plus years and give me as much access as I can possibly get, because I don't want to have to keep coming back and resizing, my credential if something's different about the use case, or if something moves or changes or whatever. I still want to vet that, but I want to drive the tax out of a least privilege allocation of a credential. So if I can take the tax and drive the tax out to provide you with a least privilege credential based on your access rights or your token, or the way that I'm looking at who you are within the organization, what type of systems you should have rights to, and I'm dealing with all of these controls downstream based on that identity and the policies associated, then I can take the best practice out of, as an example, creating a short-lived credential for an individual session, maybe, and then flushing that credential. And now I'm dealing with much less opportunity for a leaked credential to cause me a problem. And I'm looking to try to abstract you away from as much of those credentials as I possibly can. And then part of this is where we kind of get into that privileged access management space. And initially, I think we had this, people were asking us, because we handle credentials so well in Vault from a machine standpoint, tremendous scale, extreme speed, lots of policy, audit control. There were so many reasons why people really love this. And they said, but we have to have these additional engines to deal with things like privileged access management. Can you provide better human workflow in Vault? And we started with something called Watchtower, which was going to do things like session recording, and we were going to add some of those features to Vault to take on some of that privileged access management. But the more that we got into it, the more we realized there's some anti-patterns here. You still need to have things like an SSH bastion host key. You still need to be on the VPN. You still need access to the privileged access management system itself. The privileged access management system is not doing least privilege necessarily. That's probably giving you a privilege escalation to, something approaching sudo. And even though you only have rights to work on, or you should only be working on 2 of the systems, we'll say, on an individual host, because you have this sudo access, you can see everything on the host, right? You have visibility to much more than maybe you should have. And so as we looked at these patterns and we saw these complex nested interactions, we realized that there's probably a better way. Maybe we can create a secure proxy on the desktop and then create a worker that's right down at that target system or as close to that target system, and create a secure tunnel, wire it all up, instantly, and then create a secret, inject it on your behalf for the downstream system with the least privilege access pattern. And now I can do, you don't have credentials until you call for them. We create them on the fly, automate everything downstream. So now I'm able to deal with that. Now, when I do have to have a privilege escalation, I want to avoid all of these kind of the challenge of the gaps, if you will, improperly scoped tokens, a bunch of them. I don't necessarily want to expose you to a VPN. How can I make sure that I'm keeping that window down as tight as possible by doing a least privilege creation of a credential sort of on demand? And so I want to do things much more dynamically. And this gets us into the time to live capabilities around Vault. So if I'm creating a particular credential, maybe I want to scope it to an individual interaction, or 45 minutes, or 2 days, or whatever that is. And then I want to flag somebody so that we can watch this fairly closely or whatever. But the point that I'm making here is the more ephemeral that we can make our secrets and the way that we create them, destroy them, and so on, the stronger we are in terms of defense and forensics, and the tighter that identity can get. So the longer lived this thing is, the wider that window is that an attacker can exploit. And so when you see things like, there's this pretty funny Uber, there's some DMs between a couple of the folks that were involved in the breach, and they just got access to a shared drive inside the network that had the password. Oh gosh, it wasn't ServiceNow. It was one of the core orchestration systems that allowed them to see everything that was going on back there. But they got a password that was sitting in the clear, and then use that to escalate their own privileges and do get some work done. As we looked at something like that, it's not that you may still end up with a password out on the file system someplace, but if it's very short-lived and we can cut it off very easily, and you see that that a password ended up getting leaked, but that password died 6 months ago, right? Then your audit trail on looking at a 3-day password, right? If I need to do forensics and I'm looking at 3 days of log information on where that password went, the hunt is much easier to identify what could possibly have been breached under those conditions than if I'm dealing with like a 10-year credential and we're on year 8. You know what I mean? Like, that's just heavy forensics, very difficult to narrow down what the attacker had access to before that credential got flushed and we moved on to another credential. And so then we can get into, even more detail on how we get into things like credential access patterns. We don't want to store any credentials in the clear anymore. So I want to do things like tokenize credentials. Most of the breaches, if we look at things like SolarWinds started because somebody left it literally was SolarWinds 123 bang as a password left in an open GitHub repo that was publicly accessible. And so most breaches are going to come in because of a stolen or lost password. Even some of these crazy large-scale attacks that we've seen, in the news, it's because things were being stored in the clear. So if we have some form of indirection, and again, this is where Vault comes in, where I can, even if I'm dealing with static, long-lived credentials, if I can at least scrub them all with token access. So you have to assert your token to Vault to see whether or not you have rights to the static credential, which I'm not going to share with you, right? And then I'll leverage the static credential on the back end, but none of that is not actually getting stored anywhere. The core secret is, or it's being stored encrypted, I should say. But you are not going to be storing that. What you're going to embed in your source code, in your repos, and the things that you're working are going to be things like your token or an encrypted complex key. At any rate, we want to begin hiding that and scrubbing it so we're not dealing with secrets in the clear. Then we start looking at things like lateral movement. So once I'm on the network, how do I transgress? How do I go east-west? How do I get between, from this availability zone to that availability zone, from this account to that account? Because there are access rights that bridge me between these different areas of your network. And so I want to look at how do I make it harder and harder to have this lateral movement in the network. And so this is really where I really want to base my load balancing, my firewalls, my access conditions. So think authorization, authentication, routing based on identity and a strongly attested identity. So when you have a system that's out there that is trying to call across the WAN, let's say I'm going between a GKE and that private data center that we were talking about, where I need to do a least privilege right to a mainframe for financial transactions that are happening in the cloud, I'm going to need to find a way to tunnel through the network on a dynamic workload that's being created. These workloads are being created and destroyed. New identities are being created and destroyed. And I'm going to need to find a way to orchestrate the connectivity all the way back through the DMZ, all the way back to a mainframe, as an example. Now, the reason I'm talking about it in this heterogeneous form factor is because I think we think about these types of things more in the containerization world, right? Container to container orchestration, communication. How do I find another service? How do I route to that service? We do a lot more of that in like the Kubernetes ingress controller topologies and CNI and container naming and so on and so forth. So we think about this a lot more deeply on the container side. It seems to be a little bit more rare that we think about it more holistically across all of what we're doing from a multi-cloud environment. And so I think it's helpful sometimes to bridge between that containerized world into more of a hardware-driven world and figure out how do I still apply that same thinking of a mesh style connectivity strategy using layer 7 networking intentions. And when I use the term layer 7 networking intention, I mean service A can talk to service B, which can write to database Y. That is a hard and fast application level networking intention. This is how these things should route. And behind that, the IPs can be changing all the time. I could be in a different cloud today than I was yesterday. That was a container, it's now a VM. Whatever it is that I'm doing around the workload or how I'm moving it, how I'm practicing my resiliency, my least privilege access. Maybe I want to change the credentialing. I want to rotate my X509, but I want that completely out of the path of what a developer has to do on a regular day-to-day basis. I want to think of this more as a centralized service where I implement those best practices for how routing happens, but I'd rather do it at that DNS layer, right? The name of the service A, service B, database Y. I want to use those names, and I want to attest to those names with an identity, which is going to be a credential, a certificate. And if I've got proper certificating, if that's right, if that's even a word, and I can always attest to those certificates, those identities, then it really doesn't matter to me what IPs that's on. I need a way to register those instances, understand what the healthy IPs are that are going to be used for routing, and I need to be able to share that metadata with things like load balancers and firewalls and so on. And now I can do things like, awesome, they're going to route, and here's the rule for how it needs to enforce mutual TLS. I'll need to have a handshake. It'll need to be encrypted for my transaction level security. So centralized approach to deal with lateral movement. And that gets me really into that zero trust. Only rules that have been approved are the ones that will govern how traffic is routed. And then exfiltration. Exfiltration really gets at how do we get at decrypted information? Well, we're dealing with a lot of this as we go along. Right now, I'm dealing with credentials. Well, now they're very short-lived. They're moving very, very quickly. When I have the need for privileged access management, I'm doing a least privileged last second creation. I'm making these things a lot more ephemeral in nature. So leakages are less of a threat to me. When somebody does get a hold of a credential, it's probably already dead because our time to lives are short enough. So I'm doing a lot on the credentialing side on the attestation of identity. I'm doing a lot more around identity and attestation and creation, destruction, revocation of privileges and so on. And now I'm getting into, and then now I've started dealing with east-west and how I connect and under what conditions do I connect, what type of encryption policy. So now things are encrypted on the wire centrally and by default. Now, but what about when somebody does request data from a data source or, a user just entered a social security number on a UI? How do I deal with protecting data at rest as well, not just in flight? And we want to do it in transit, but also on disk. So we've talked a little bit about applying that mutual TLS policy to my service intentions. I can say, here's how these services should be talking to each other. Here's the encryption that they need to be running as they do it. Now, how do I drive the identities and bring these two sides of the house together? And generally, this is where we're talking about like Vault and Consul working in concert with each other on those credentialing elements, on creating things like their certificates that are going to be required for mutual TLS handshaking. But I also need to do things like pass. I want to do real-time on-the-wire encryption of sensitive PII before it lands in storage. So as I mentioned before, that HSM will gladly, the hardware security module will gladly decrypt that data and hand it to me if it sees select star from customer from what looks like a trusted IP. And you had the right credential for the database, Scott Tiger from my Oracle friends who remember that far back. And so I'll get the decrypted data because it looks like I have rights to do so. So I want to introduce Vault between those two endpoints so that I'm actually scrubbing the data or encrypting the data before it actually lands on disk. And I want to do that in flight. Maybe I don't even want the UI to show social security number. Maybe it only shows the last four. So I can get really fancy with how I want to do the encryption. Like I can establish a library, alphanumeric characters only, or alphanumeric special characters. I can establish what kind of library that I want to use for my transform engine. I can spell out exactly how I want it to be. Maybe I want to call out to a random number generator to add a nonce or whatever it is that I want to do. I can get really, really fancy with what I'm doing from an encryption standpoint on the data itself. So before it lands anywhere, before it lands in a buffer, before it lands, maybe I want to pass it through this transit encryption where Vault encrypts it on the wire and then fires it at whatever storage it's going to land on. And now I'm dealing with it. I'm narrowing that window even further and making it really hard for an attacker to exfil any data in the clear without defeating Vault, and then defeating Vault and the backend database, defeating Vault console routing instructions, or not letting you see everything on the DNS. I'm just narrowing all of these little individual pieces, making it harder and harder for you to execute the attack. So if we go kind of window by window, we're trying to close all these windows down as much as possible through these various approaches, advanced data protection methodologies, routing, authentication, authorization at the networking tier, strongly attested identity at every aspect, and then secure connectivity that's finally tuned and audited for a human access to some form of sensitive system. And now we're trying to deal with a lot of these MITRE controls as we think through this. So I'll just end real quick because we're right at time. I would love to have any questions that you may have. But these are the products essentially that we think through as we're working through our zero trust approach to how we deal with identity, access control, user access. If you have time and you're able to get to LA for the first week of October to join us at HashiCorp, I'd love to meet you, shake your hand, grab a beer, something like that. If you have the opportunity, you'll also get a chance to interact with product management and see where we're going. We're going to make several new announcements at HashiCorp, so little plug for our event there, but I'm sure we can also see you at things like reInvent. This is the last use case that I put together for that modern to somewhat more legacy or on-prem, off-prem, how these products end up working together to establish that trusted connectivity forwards and backwards. I'll stop there. Really appreciate the time. I know we're up against time. If you have to drop, feel free, but I figure I'd open it up for a couple of minutes here for questions.
Awesome. Thanks, Michael. Just a reminder, if you guys do have questions, make sure to pop them in the Q&A box at the bottom. But as we're wrapping up, I just want to make everyone aware that our recording or our webinar has been recorded today. And so we'll send an email out with that link probably 1 to 2 business days after today. If you can't find it there, you can always go to our YouTube channel and search this webinar and you'll be able to find it there as well. Any questions? I think we're good, Michael. So appreciate everyone for joining. Thank you guys so much. We hope you have a great rest of your day.